Hello there! Good day everyone! I'm Maika F. Alcabasa, BSED Mathematics 3A. And today we're going to have a tutorial about null and alternative hypotheses on hypothesis testing. Let us know first how to formulate and write the null and alternative hypotheses on hypothesis testing. Let us also know first about hypothesis. Hypothesis is basically a statement about a target population. Also, let us know the statistical hypothesis. It is an assertion or conjecture concerning one or more populations. There are two forms of hypothesis, the null hypothesis and alternative hypothesis. The null hypothesis is the hypothesis to be tested, and it represents what the investigation doubts to be true. It also written with the symbol H subscript of 0. The alternative hypothesis. The alternative hypothesis can be written with H subscript of 1 or H subscript of A. Is a statement that contradicts or disagrees with the null hypothesis. Take note the word contradicts. So let us state the null and alternative hypothesis of each of the examples. So let us have first the example 1. The average age of bus drivers in Metro Manila is 38.8 years. So we're going to state the null and alternative hypothesis of each examples. So what are the clue in these examples? So the clue here is the word S. So it means the null hypothesis is the symbol that we used is equal. So what do we call with this symbol? This is what we called population mean. So this is the null hypothesis, and this is the equal signs, and 38.8 years is what we call the value of the population. By the way, we can write our null and alternative hypothesis in symbols or words. So now this is the value of alternative hypothesis. The population mean must not be equal to 38.8 years. So always remember that the alternative hypothesis, it always contradicts to the null hypothesis. So next, let us move to example 2. The average number of calories of a low-calorie meal is at most 300. So the clue here is the word at most. So the symbol that we used is less than. Then for the alternative hypothesis, the population mean less than 300 calories. So less than here, so the null hypothesis is equal to 300 calories. So let's move to example 3. A DTI representative wants to test at 99% confidence level whether the average content of soda X is less than 330 ml as indicated in the label. So there is the word less than. So we can write the null and alternative hypothesis in words and symbols. So let us write first the null hypothesis, HO. So we can write this in the average content of soda X is less than. So can be greater than or equal to 330 ml. The average content of soda X is greater than or equal to 330 ml. So in symbols, we can write this as like this. So now, what is our alternative hypothesis? Our alternative hypothesis is the average content of soda X is less than 330 ml. And the symbol should be like this. So let's move to another example. A company has stated that their straw machine makes straws that are 4 mm diameter. So take note that the average or the diameter of the straws is 4 mm diameter. The worker believes the machine no longer makes straws of this size and samples 100 straws to perform a hypothesis test with 99% confidence. So now we're going to write the null and alternative hypothesis. So in this case, the null hypothesis should be like this. So remember this, the null hypothesis is the certified belief innocent until proven guilty, so to speak. Notice that these mathematical opposites, every possible scenario is contained when we look at the total of the null plus the alternative hypothesis. In other words, either it's for or it's not for the thing that would encompass any size straw. So they have to be mathematical opposites, and when you take them both together, it's going to cover basically all possibilities of what the machine might be doing. We don't have any greater or less than here because the actual problem doesn't say anything about greater than or less than. It just says 4 millimeters or not 4 millimeters. So you need to read everything carefully. So this is really the answer to the problem. But I won't go just a touch further and just kind of discuss into the problem. It says we're going to test this by taking samples of 100 straws. So as we go further in the hypothesis testing, you'll need to know how many samples did you actually choose to test the hypothesis. And that's usually the variable. So in this case, it's 100 samples, and it also told us that the variable C is 0.99. You have 99%. You need to put it as a decimal. That's what the value of C is. Sometimes we're going to be using C. Sometimes we're going to be using alpha. Alpha is just simply 1 minus C. So 1 minus 0.99, so 0.01. It doesn't really matter if the problem tells you the level of confidence C is 99%, or if it tells you the level of significance alpha is 0.01. It tells you the same exact information. Alpha, C are directly related because they have to add up to be 1. So again, we're not doing testing, and these problems we're just writing the hypothesis down. So this is the answer for this problem. So the next one, the doctors believe that the average teen sleeps on average no longer than 10 hours per day. A researcher believes that teens on average sleep longer. Write the null and alternative hypothesis. So we write down the null and alternative hypothesis. Now, the difference in this case is notice that the wording is very different. Doctors believe that the average teen sleeps no longer. No longer means that doctors believe that they might sleep 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, but as soon as you get to 10 hours. No longer than 10 hours means no longer than that. So this is clearly not a case when we have equals or not equals because the wording of the problem is telling us no longer than 10 hours. So we're going to write the null hypothesis accordingly. We're going to use this mu because we're talking about the average amount of time that teens sleep. So this is a mean value. It's the population of teens should be less than or equal to 10 hours. So make sure you understand this. The doctors believe the average teen sleeps on average sleep no longer than 10 hours, less than or equal to that. So if this is the case, what will be the alternative hypothesis? Well, actually says a researcher whose challenger believes that teens average sleep longer than this. That means that it has to be greater than 10 hours. So if you were asking to write the null and alternative hypothesis, this is what you would be expected to write the null hypothesis. Is saying that the teens do not sleep any longer than 10 hours. So any time up and including 10 hours, that is what we call the null hypothesis. But the researchers come along and says, no, on average, I think teens do actually sleep more than that a greater. Notice there is no equal sign here. Because the equal sign here, so all the way up to and including 10 hours, this would be 10 point, 11 hours, 12 hours, anything greater than 10, right? And then exactly 10 will be included here. Notice that the null and alternative is our mathematical opposite of one another. In other words, the first hypothesis includes every number up to and including 10. The second one includes all numbers beyond 10, so together they include for how many hours a team could possibly sleep, and that's how all of those hypothesis tests are going to be set up. When you construct the null and the alternative, you look at together. It should encompass all possible answers for what could possibly happen. So this is the answer. So that's all. I hope you learned something today. Thank you!